Hello friends, today in this video we are going to see about AES algorithm. AES stands for Advanced Encryption Standard. Okay, so this algorithm, it is also a symmetric cipher. DES is also symmetric cipher and AES also symmetric cipher. Symmetric means both sender and receiver will be using a same key, and this is also coming under block cipher. Your input text will be separated into different blocks. Okay, so in DES algorithm the block size is of 64 bits, but in AES algorithm the block size is of 128 bits. And key in DES algorithm, key is also 64 bit, but here the key size is 128 bits. Okay, and then in AES algorithm we are following three matrix. Okay, one is input matrix, okay, and the other one is state matrix, and the third one is key matrix. Okay, so these three matrix we are using in AES algorithm. Okay, input matrix will be represented as IN0, 1, 2, 3 up to 15 we will be representing. Okay, the input will be represented in this form, and then this is called as your state matrix. So state matrix will be represented as S00, S01, S02, 03, and then S1011, like this it will be represented. Okay, so in this place 00, the first value represents the byte number and the second value represents the word number. Okay, so for example here 10 means the one, it is a byte number 1 and word number is 0. For representing that we are using this kind of state matrix, and state matrix mainly used to store the intermediate value. Okay, and then IN0, this 10, it is of 8 bits. 8 bits means 1 byte, and then word equal to 4 bytes combined together will form one word. So 4 bytes means IN0, IN1, IN2, IN3. So all these 4 joined together will gives you one word. Okay, so one column is called as one word. Okay, so that is represented as W lambda equal to W1, W2, W3 and W4. Okay, next one is key matrix. Key is also of 4 cross 4 matrix. It is represented as K0, K1, K2, K3, K4, K5, K6 and up to K15. Okay, next we are going to see about what are all steps we are going to follow in AES algorithm. Okay, in AES algorithm there are totally 10 rounds are there. Okay, in DES algorithm we saw it is 16 rounds, but in AES algorithm we are having 10 rounds. Okay, so every round will take one key. Okay, so every round will take one word of key. Okay, that we will discuss later. Here we are following 4 steps. First step is pre-processing, and second step is substitution, third step is shift row, and fourth step is mix column. This mix column, it is a special option. Why we are calling it a special option means in the last round this mix column step will be skipped. Okay, so 10 rounds are there, up to 9 rounds mix column we will follow, but in the 10th round, final round, we won't be using this mix column step. Okay, and final step is add key. Okay, next we will see about key expansion. Okay, as I told you before, key we can use different bits. For example, 128 bit also we can use, 192 bit also use, and 256 bits also can be used. If you are using 128 bits, there are totally 10 rounds will be there. If you are using 192 bits, 12 rounds will be there. If you are using 256 bits of key, then 14 rounds will be there. Okay, now we will see about key expansion. I told you one column is called as one word. Okay, so for every round one column will be given as input. Okay, K0, K1, K2, K3. So in this case the key will be expanded from W0 to W43. Okay, so W0 up to W43. So this will be taken as input, and that will be get expanded up to 43. Okay, so totally 44 columns will be there. So from W0 up to W43, totally 44 columns will be there. Okay, I told you 10 rounds are there, right? So 10 rounds are there. Every round will take 4. Okay, every round will be taking 4 words. So every round is taking 4 words, means 10 into 4 will gives you 40, and remaining 4 is there, right? So that 4 will be given as input to the before round. Okay, so in the first round that 4 word will be given as input. Okay, and then in all the 10 rounds 4 words will be given. So totally we need 44 words. Okay, next we will see about the diagram. This is the actual diagram. Okay, so here 128-bit plain text is there. So that plain text is going into add round key. Okay, this is the first round. Okay, add round key. See, I told you, right? From word 0 to word 3 will be given as key in the add round key. Okay, so here rounds is not yet started. Okay, so this is add round key. First 4 words will be given to this round, and next only rounds are starting. So from round 1 up to round 10. So in every round your key is given as input. In the round 1 from W4 up to W7 is given as key. For round 2 W8 to W11. So like that it will be keep on going up to we are having word 43. Up to word 43 is there. So that will be given as input in every round. Every round the key is different. It is not same. We are not giving same key. Every round we are giving different keys. Okay, in the key expansion step key got expanded, right? That key expanded key we are giving as key in every rounds. Okay, next we will see the steps. I told you, right? Here we are having 4 steps: pre-process, substitution, shift row. In every round what is all happening we will discuss. Okay, so first round is pre-processing. Okay, so pre-processing. In pre-processing round what is happening? For example, I have taken this as input array. Okay, so this is the plain text that is represented in matrix format. Okay, and this is the key from key we have taken W0, W1, W2 up to W3. So up to W3 key is taken for up to W3 key will be taken as input in the add key round. So here pre-processing round will take W4, W5, W6 and then W7. So these words will be taken as a key in the pre-processing round. So here what is happening means every corresponding element will get XORed. Okay, for example, here in the plain text 1 is there and in the key place EB is there, right? So 1 XOR with EB. Okay, you know the XOR operation, right? So XOR operation means if same value, if you are having same value, then the answer will be 0. If it is 0, 0 also 0. If it is 1, 1 also 0. But different value means the answer will be 1. So using these steps we have to follow. We have to find the XOR value. So 1 XOR EB. We have to write the binary value for 1. Okay, 0 0 0 0 0 0 0 1. Okay, then for EB, E means A stands for 10. Okay, 10, 11, 12. Sorry, A, B, C, D, E. Okay, so it is 14. So 14 the value is 1110 and A means 10. So that is represented as 1011. Okay, so you have to find the XOR. When you find the XOR, you are getting the answer as EA. Okay, so every value is getting XORed and you are getting this as output. So only one value I have did. You can check for all other values. This is for example I have taken to make you to understand. This is not the exact thing. Like plain text is getting XORed with the key. Okay, that process is called as what? Pre-processing. Okay, and next step is substitution. So substitution in AES algorithm, I have shown you a S box. So same like that in AES algorithm also S box is used, but in DES algorithm 8 S box were there, but in AES algorithm only one S box will be there. So in S box like from 0 up to F rows will be there, same like that 0 up to F column will be there, and every column and row will be having a value. Okay, so 5 4 3 0 like this values will be there. I have not written the values. Okay, only I have, for example, I have written some values, but every row and column will be having a values. What we have to do is, first is EA, right? So in this pre-processing round we got the answer as EA as answer, right? So for this value, how to find the S box value, I will tell you. So EA, right? So EA means E stands for the first value will represents the row, and second value represents the column. Okay, so the row and column where it is getting intersected, that value will be taken as S box, taken as substitution value. Okay, first is E, right? So E we have to find in the row wise E, this is coming in row wise. Okay, next column wise A. Okay, E and A. Okay, if you find E and A column wise, you are getting the answer 87 as intersected value. So in the place of EA, 87 will be represented. So the answer will be like this. So 87, for every row representation if you take, you will get this as answer. Okay, and next we are moving on to the next step, that is your shift row step. Okay, in shift row step what we have to do is, totally we are having 4 rows. So every row how we have to shift, for example first row is there, means in first row you are not making any shift, so no shift. Okay, next for second row you are doing only single shift, only one value you are shifting. Okay, then for third row you are shifting the value by 2. Okay, 2 bits will be shifted, all left circular shift only. Okay, and then for fourth row you are doing it by 3 shifts. Okay, for example A B C D is there, right? So if you want to shift, means what you will do, left circular shift, so this A will come here. Okay, next B will be going to this place, and C will come to this place, D will come to this place. If you write like this, so B C D A. Okay, understood? So this is called as left circular shift. So for example 2 times you are performing, means this is single time. So 2 times you are performing means what will happen, again you have to perform. So B will come here, next C will go here, D will come here, then A will be coming here. So you will be getting C, D, A and then B. Okay, this is 2 times left circular shift. So 3 times left circular shift means what will happen, this C will go here, then D come here, A will go here, then B will go here. So answer will be what, D, A, B, then C. So this is 3 times you are performing left circular shift. In that way if you perform, you will get this as answer. So first row we are not performing any shift, so as it is you have to write 87 F2 4D 97, and the next row only one shift you are making. So what will happen this, okay, only one times we are performing a shift, and you will get this as output. Okay, this concept is called as shift row. Okay, and next we will see about mix column. Okay, mix column, I told you this is a special step. Why? Because in 9 rounds we are performing this mix column, but in the 10th round you are not performing this mix column step. Okay, so mixed column what they are doing means, they will be taking first column. Okay, first column is taken and it will get multiplied with a standard 4x4 matrix. So this is a standard 4x4 matrix. Every column will get multiplied with this standard 4x4 matrix and it will give you the answer. Okay, in this case what is happening, no, it is not normal multiplication. For example, in matrix multiplication we will be performing addition and then multiplication, right? So in the place where and all addition is coming, we are performing XOR operation, and in the place where multiplication is happening, in that place you have to perform left shift plus conditional XOR. Okay, this is called as mixed column step. And the final round is what, add key. add key round, it is same as preprocessor round. Okay, so the answer, the result what you got from the mix column, that will be given to add key process. So add key process is same as preprocessor. In preprocessor round, what is happening? Okay, in preprocessor round, every corresponding value will get XOR, right? So same step, same we are following in the add key. So the answer will be get XORed with the words. So the words are what? Finally words will be there, right? So up to W43, W42, W41, W40. So with this 4 words key you have to take, and this will get XORed, and final answer you will get. So this is all about your AES algorithm. I hope you understood the video. Thank you for everyone.